Hello guys, welcome back. We are going to do little practice today. Okay, so this is the question that we have on the Leetcode. This is the first question we have in the EG section, right? So what we will do, we'll do the hands-on on this question, right? So I think most of you you already have done this question, right? So this is a little tricky question, and you can do the multiple approaches you can apply here, and let's understand this question. Okay, so first of all, we have given an array of integer that is called nums, and as you can see in the example, we have given nums 2, 7, 11, 15. Okay, and an integer target that you can see here in the target. Now it is saying that return the indices of two numbers such that they add up to target, right? We have to return the indices of the two numbers such that they after they added, right, added up to target, as you can see. Okay, so you may assume that each input would have exactly one solution, and you may not use the same element twice, right? So you can enter the answer in any order, right? So let's suppose what we are trying to see here, right? So first of all, we have given 2, 7, 11, 15, right? We have given. Okay, this is nothing but an array. Okay, so if we'll represent this into array, it will look like this one. Okay, so index is what? 0, 1, 2, 3. These are the indices, right? So target we have given. What is target we have given? Target is 9, right? So if we'll do the sum of the two numbers, let's suppose I am taking, this is nothing but our nums we have given. So nums at what? Nums at 0 is 2, at nums at 1 is what? 7. If we'll do the sum, right, if we'll do the sum, it will become what? 9. So indices 0 and 1 is the output, right? Indices 0 and 1 is the output. That's why you can see here, this is the output. I think you got the answer, solution, right? How to do that, right? So what we will do, actually, we will do the sum like this. Okay, and if the sum, this target is exactly equal to this target value, it means these indices we have to put into an array and we have to return, right? Got it? You can do that. There is another let's see, coming back to here, sorry, okay, coming back to the another example, as you can see. Okay, give me 1 minute. Okay, okay, so the another example we have given, right? And this example is you can see what we have given. We have given 3, 2, 4. This is an array, right? And target what we have is 6. Now if we'll do the sum, this can be valuable 3, and we'll do 5. It will not happen, right? 3 plus 2 is equal to 5, so this number will not count, right? So this indices is not going to be in the answer. Now we'll come back to 2 here, and we'll check 2 and 4. So indices 0, 1 and 2. This time if we'll do the sum of these two number, right, we'll get our indices 1 and 2, right? And we are the sum is actually 6, right? And that indices is our output. So you can see indices is 1 and 2. Now another example, third we have, in which we have 3 and 3. If there is only two element is there, if you'll do the sum and it is equal to the target, means this is the output 0 and 1. So this indices is the our output, as you can see, right? So what we can do now we'll understand about the approach, how we'll do the implementation. Okay, now one thing, see, we have given this array, right? We have given one array, right? And you can see the output, you can see num we have given, and another is target we have given, right? So on this num, what we can do, first we'll take 3. Let's suppose we'll take 3, then I will check with another these 2, right? So if 3 is, we are checking with 2, 3 will with 4. No, this is not, this will not work, right? Then we'll take from 2, right? We'll check with 2, and we'll check with you can check with a combination of 3 also. We'll check with 4, right? So this combination is matching, right? If another element will be there, we will check with 2 and 3 with another element, like this, right? We can do. So as you can see, we are repeating the element, right? We are going with 2 loop, I and j. If this is I, right, and we are moving with like for I equal to, we will go to full j from here to here, right? As you can see. Or if we are at I, we'll go to this will be our j from here to here, right? Let's suppose we have given 1 2 3 4, right? If we want to do the combination, 1 will go with all the element, right? So if it is I is at what, 1, so j should be what, j should be start from here to here, right? Because 1 2 1 3 1 4, like this we will go, right? 1 2 1 3 1 4, like this combination should go, right? So I will start with I equal to 0, as you can see 0 index, and j I will start with what, 1. Okay, so what will happen each time when I is coming here, it means what, now j should be go to here. It means I will not say directly 1, but I will say I plus 1. J will start from what, I plus 1. Okay, so let's see the code, right, how we'll do that. Okay, so I'm coming back to here. I will write the code here. Okay, let me full screen this one. Yeah, okay, we are good to go. Okay, now what I will do here, I will write the code. First of all, we have given nums, right? We have given what, we given nums and target. So I will make the loop on this num. Okay, first of all, I loop. For the first loop, what we have to do, we'll start I from where, I should start from 0. Okay, and we'll go to, I should go to what, less than what, its length, nums dot length, right? We'll go to the nums dot length. Now what we should do, I plus, right? So that increment each time. Now we'll go to the j, and j we know that j will start from where, I plus 1 index more from I, right? And j should be less than what, nums dot length. Okay, this should also go, and j plus. Now what we will do, just we'll check if our num at j, if our num at j is equal to target we have given, and we'll do minus what, num at I. If it is equal to, I'll explain this one, don't worry. So first of all, what we'll do, we'll return what, in new array we'll make, and we'll say what, it will go to what, 2 thing, like this. We'll pass I, and then we'll pass j, like this, right? So it will return. If we don't have, if there is no any such element, we'll return then we will return what, null. This should be nothing but, you can pass empty like this, or you can pass null like this. Empty means I or j will not pass, means we'll do like this. Okay, let me explain this one. Okay, first of all, where is my pen? So what I'm trying to do here, we are going I and j 2 loop, right? I and j 2 loop we have. So here we are going, we have what, a loop we have. Let's suppose we are talking what the whatever value, let's suppose 1 2 3 we have 4. Okay, and we 6 is our target, let's suppose. So what will happen, first of all, if 6 is our value, right? So when we are getting 2, right? So what will happen, if we'll do 6, right, minus 2, let's suppose 6 minus 2, if we have any element, 6 minus 2 is now what, 4. And if it is already somewhere here, right, already somewhere here, right, in this array, that is we have at here, right? So it is equal to, right? Means this is at j. If this is at j somewhere, right, means I we have already calculated. See, so nums of I is nothing but, let's suppose, 2, right? So now the remaining target is what? Remaining target is this one, as you can see. So this result will give you this 4, right? So next time when our j is coming to this point, this one, so it is equal to, once this is equal to, will return what? I and j in this. And if it is not matching any of these cases, right, will return true, right? So what will happen initially, first time will come to here, right, here. So first of all, our target is 6, right? We'll do 6 minus what? 1 means num of I. Num of I means what? When num of 0 we have at what? 1, this one, right? 0 1 2 3 like this, right? What will happen? We'll do 6 minus 1 is what? 5. So as you can see, from j will move from what? Here to here, right? Here to here. No such element is here, right? When num at what? We'll take num at what? 1. So num at 1 is now 2 we have, right? So we'll do 6 minus 2. Now it is 4. We'll move from here to here. We'll check this element. Yeah, we'll got this. We'll return there, right? If this is not the element, we'll move to next like this. So thank you guys, thank you for watching this video, right? So in this case, as you can see, we are going to loop, right? 2 for loop we have, right? And we are going to all for loop will going to n times, right? So it for all the element we are going to n into n is n square, right? So it will take O of n square time complexity. Okay, and if we'll talk about the space complexity, we are not taking any extra spaces, right? This is auxiliary expressed, so we can say that space complexity will take O of 1, right? And if you want to do you can say if you want to do the implementation using hash table or hash map, right, you can do that. Just you will have to put this value somewhere and will check that value. Okay, so let's understand now the another approach that we can do. What we can do, let me remove this one, okay, from here to here. So this approach will take one map, right, and will put the map all element and its index, you can say, right? How we'll do that? First of all, we'll take one map. So I'll take a map, and this is nothing but our integer like this. Okay, integer. And now another will take integer only, integer. Okay, so two element will take, one its element, another is its index, right? And I can give this as a map, my name, map value, and this is hash map. We can do like this. Okay, we can call in constructor of hash map using the new keyword. We are invoking the constructor. Now what we have to do, for we'll make a for loop, and we'll say int I is nothing but our 0, and we'll take I should be less than what? Nums dot length we have. We'll go to the length and then I plus plus, right? Two things will go. Now what I will do, I will do what? Map dot, and we'll put our element. First element will come from where? Nums. At nums at I, we will get the element, and its indices are I, right? So our map is have initialized with our element and its index. Now we will make another loop, and this loop will take int I equal to 0, and we'll go to I should be less than nums dot length like this, and I plus plus like this only here. Now we'll take one complement, int complement. We can give the like, let me write complement, and this complement will take what? Target. Complement is nothing but we have done, right? Nums at some value I, and which we were the coming is complement is nothing but our remaining element, right? You can say remaining element after doing the minus, right? Now what we have to check, we'll make a function if condition, and we'll say if map contains the element, right? Contains key we have. If this contains key, complement have, right? After doing the minus, right? If this is there, and one more thing we have to do, map dot will call get method, and we'll check this complement. Sorry, we'll check the complement. This one will do get if not equal to what, I. If it is not equal to I, correct? So in this case, first we'll check if it should contain, and its complement is not equal to I, right? In both case, we will return new int like this only, and we have to take curly braces, and we'll pass first I, and then we'll pass our map dot get complement, right? I'll pass the complement, okay, like this. So it will return the complement index. This is we have the map will contains complement, right? And then it will return. So let me explain this one. And finally here we'll return what, null, if we don't have anything such like. Okay, so let me take the screenshot first. Now okay, first of all we should run this one, right? Yeah, submit this one. This would, yeah, this is working. Now understand this one, what I am trying to do here. First we have taken map, so this map I am talking about. So we'll take map like this, right? And if we have this nums is nothing but like this, what we have 1 2 3 4, right? This is the array we have given, let's suppose. Okay, we are talking about, and target is 6. This is our target. So first of all, what we are doing on this one, we'll start from 0 1 2 3. This is our indices, right? So what I'll do, I'll take a map like this, and we'll put our indices like here 0 1 2 3, right? And all the element will come what here 1 2 3 4. This element can be different, right? This is nothing but our nums at I, okay, and this is nothing but our I. Okay, you got it? So we are putting nums of I is here and I here. Got it? You will get our map. Now what we have to do, we will make another loop, for loop, and we'll find our target. So our target minus num. So target minus num is nothing but our C. Okay, so nums at I, what we have, 1 we have here, right? So what will give 6 minus 1 is 5 here. We'll get here. We will check this 5 in from here to here, here to here. Next element, from next element you can say, or on this element we will check on this map. So 5 is not here, right? Next, now we will move to the next one. I will move to what, from 0 to its length. Now it is we are moving to here. Now complement is what, 6 minus 2, it is become what, 4. Now we'll check from where, on this map. Yeah, we got it. Where? Here at this index, right? So at this index you got 4, so no need to continue this map testing. And we have our I and j. So I we got where, at this location, and j we got where, at this location. So we cannot say I and j. What we are saying, after doing the complement, right, if the indices if the element is present onto the map, that indices will return from here. This is nothing but our j that we are doing in the first program, right? And this is our I. Okay, so what I'm doing to get the j. Let's suppose to get the j, this is our I and this is our j. So to get the j, what I have to do, we have to just make one map dot get complement, because this is nothing but our complement, right? So if complement index is there, that is our index, so we will get our index, and as we know, I will return. So I and j is like that. So map will contains, we are checking the complement is there or not onto the map, and we'll get our both indices, and finally we'll return this one. So this way you can implement the same program, but the time complexity is now getting changed. As you can see, there is no, we are using two loop, but we are not using nested loop, right? Now the time complexity is what? Because one loop is going here and one loop here. So it will, in both cases, we are traversing n times only, right? N times we are traversing onto the, you can say, on the nums, right? Because if there is n elements, we are doing the twice, right? But it will get counted as O of n time only. Okay, so we can say O of n time it will take. And for space complexity, in this case it will increase. Why it will increase? Because we are using map. Okay, so what will be the time, you can say, space complexity, n element we have to store, so we'll say O of n. So if you'll do the optimization, I think this is the best case in which we will find this one, right? One you can do what, you can remove one pass, one for loop you can remove, and what you will do, you can these things you can do in one cases only, right? So how we will do that? Let's see the another approach in which we will see the we will use only one for loop and we'll do the optimization. Okay, let's go. So now what we will do, actually we have taken this map, right? Now we have, after that we have taken the for loop. On this for loop, right, we are adding the, what we are adding, we are doing the map, right? We are doing put. So we will not do put before. What we are doing here, these things we will put here before this one. Let's suppose before this one, just we have to do this one, and nothing we have to do extra apart from this, right? Let's suppose like this, right? So what we are doing here, we'll find our complement, then we will check onto the map. If it contains, now we no need to do this one I index, we no need to do. Just what we have to do, we will pass our complement index and its index, right? Just very simple we have, right? You can pass I and this one. Let's suppose and run. I think it's accepted. Let me check. Yeah, it's working. Yeah, thank you guys, thank you for watching this video. If you like this video, please hit subscribe this channel, and in this case we are getting the same time complexity as the previous O of n and O of n in both time complexity and space complexity. Thank you guys, thank you for watching this video. So I'm going to create one playlist in which I will put all these easy questions, right? And because easy questions give you the concept of building logics and the, you can say, ability to handle the programming questions into the interview room. So make sure you will complete all these playlists that I'm going to upload in this channel, right? So thank you for watching this video, guys. Thank you.